Hey, in this video, I'm going to show you how you can use decoys and packet fragmentation to further obfuscate yourself while using Nmap and doing Nmap scans. So what I'm going to do is actually run Nmap, and I'm going to do a stealth scan. We're going to also specify the WAC capital D for decoy, and I'm going to be using random IP addresses because I don't actually have the authority to use public IP addresses, and I don't want to get in trouble. And I want to preface this by saying, of course, always have permission to do anything. Definitely don't want to get yourself in any legal consequences. So we added the decoys with a WAC D and then the RND 3. So Nmap will automatically generate us 3 random public IP addresses. Cool. From there, I want to do the -V for verbosity because I want to see what's going on under the hood. And from there, I'm also going to put a -P for the ports. I don't want this scan to take too long. I'll do the first 1,000 ports. I think I put another 0 on there. You want to do the first 1,000 ports. And now I'm going to be doing the scan me.nmap.org because, well, I have the okay to use this website, and so do you. So does everyone. That's what it's made for. I also want to append this, or not append this, but I definitely want to put this in a file. So I'm going to do home Cali documents, and I'm going to call this decoy.scan.txt. Okay, that looks good to go. And one last thing I want to do is actually run Wireshark because I want to capture these packets and I want to make sure this decoy is running. And that's the whole experiment. That's the whole purpose of this lab. And I'm going to hit this enter right now. Okay, so the scan finished. We can tell by, I'm going to concatenate that file path, file that was just created, documents, and decoy scan text. Yep, so it went through, it completed, it was successful. We see these ports that were open, because we did specify those ports. But what I want to do is, it doesn't really tell me in this file if the decoy went through, and we want to make sure it went through. So let me stop this scan. Let's scroll up a bit. Alright, so here we are. This is my public IP, or I'm sorry, this is my private IP, 172.16.16.134, and it's going out to nmap.scanme's web public IP. This is their public IP right here. We send a synchronization, and right underneath mine, you do see a public IP that was randomly generated by decoy. So here's 1, here's 2, and here's 3, and we did specify 3, right? We specified 3. So again. Here we are. Oh no, sorry, that's not us. Here we are. This is my public. This is my private IP. And after that, it went through this dynamic. It went through this chain, this round robin chain of random IPs. So here's 1, here's 2, and here's 3. And then it went back to mine. So it uses some kind of a round robin approach with this random decoy generation. Cool. Another thing we can do is, so I'm gonna keep this same input for our scan, but we can also fragment packets, which is another way to evade firewalls, and that's with a -f. And by default, it'll take this packet and make it the smallest possible size, making it 8 bytes. So let's turn this on again. Hit enter on the scan. Okay, it's going to take a bit of time because the packets are fragmented, so it should take a little bit more time. And as you can see, all these fragmented IP protocols are coming through as well, meaning that WAC F is fragmenting our scan, and this is still scanning. We can see on Wireshark that it's still scanning. And I'm going to pause this for the sake of clarity. So the scan is still being conducted. I don't know if it's finished, but we can see it's fragmented each request. So you're going to see duplicates, but it's not really duplicates. So here's 3 instances of my private IP going to our destination, fragmenting those packets. So as you can see, it's fragmenting those packets. So here's 3, and then it uses that round robin approach again, and then with the decoy, and then here's the additional decoy. Here's one of the public IPs. Here's the next one, the second one, and here's the third one, 13.2.36.174. So we can see, and I'm going to cat this file once more. We can see in real time with Wireshark that the decoy is working and the packet fragmentation is working. One last thing I want to go over real quick is the maximum transmissible unit. So not only can we fragment packets, and as I mentioned, the -F only does 8 bytes by default. We can change it, so we can throw in, if I can get there, I gotta upgrade my resources. I gotta upgrade my hardware. We're gonna do a whack MTU for maximum transmissible units, and we can specify 8. We can do 16, 24 increments of 8, 32. You get the idea. Up to 128, and I'm gonna do 64 because you know what? I don't want the scan to take too long with the fragmentation of the packets. I'm gonna run that, and I'm gonna try to see if I can open this real quick. Yep. And I want to filter by the source, and I want to filter by the info. So here we are. We can see that it's sending out to our destination. Here's my source, and here's the 3 randomly generated public IPs. We can see that the length is different as well. It's not the same as it was with our first scan. So, and there you go. That's how you can use decoy and packet fragmentation to avoid firewalls with Nmap.